In this short video, I want us to explain the principle of electromagnetic induction, which was first introduced in grade 11 under Faraday's law of electromagnetic induction. You can see here I have the magnet and the magnet with the magnetic field. You can see the magnetic field moving from the north pole to the south pole of the magnet. And here is the bulb, which will easily show us anytime there is an induced EMF in that solenoid. And we also have the galvanometer, which we can use to detect the direction of the induced current. So let's start and see what happens when this magnet moves in and out of the solenoid. So as you can see, that once the magnet is moving towards the solenoid, an EMF is induced in that solenoid, and that induced EMF is what produces the current. And electromagnetic induction is a fundamental principle we normally use in physical science that describes the process by which a changing magnetic field generates electric current in a conductor. This phenomenon was first discovered by Michael Faraday, but remember from grade 11, Faraday's law of electromagnetic induction, we state that the EMF is equal to the rate of change of magnetic flux. And the magnetic flux itself, which we represented by phi, if you still remember the symbol, depends on the following factors. It depends on the strength of the magnet, the magnetic field, and it also depends on the orientation, the position of the coil relative to the magnetic field, and it also depends on the area. But we are not going to focus on the calculation here in grade 12 under electrodynamics. So you can see that this principle explains clearly how a generator functions, how generator works, because generator uses this principle in order to function, be it AC generator or a DC generator. As you can see in generator, you will see that as the coil rotates in the magnetic field, there is a change in the magnetic flux. And it is this change in the magnetic flux that produces the induced EMF. And as long as the induced EMF is created, that induced EMF produces an electric current as long as the circuit is closed. As you can see from our diagram that we are using a closed system. We are using a closed circuit. The induced current is in such a way that it opposes that change in the magnetic flux. If you notice it there, if you notice the direction of the induced EMF, you can see I'm showing you the direction of the induced EMF. You can see that the direction of the induced EMF is in such a way as to oppose that change in the magnetic flux. Like I've said before, electromagnetic induction is used in generators. And remember, in generators, it converts mechanical energy into electrical energy. So anytime there is a rotation in the coil of wires in the magnetic field, it induces electric current. And that is basically what we call electromagnetic induction. And I hope that this video have helped you to understand this basic principle.